Hi and welcome back. In today's coding session we will talk about the famous Xor or exclusive OR problem. So, what exactly is the Xor problem? It is a classic problem in artificial neural network research. It is the problem of using a neural network to predict the outputs of Xor logic gates given two binary inputs. An Xor function should return a true value if the two inputs are not equal. We can see here, when the two values are not equal, 0 and 1, the output should be a true value, which is 1. And also here, 1 and 0 should return 1. But when the binary inputs are equal, 0, 0 or 1, 1, it should return a false value, which is 0. The way we are going to solve the Xor problem is by using the logistic regression that we learned in the previous tutorial. So, if you missed that video, I will leave a link down in the description. Before we start solving the Xor problem, we first need to remind ourselves of how the OR, AND and NOT AND logical operators work. We will first talk about the logical OR. How does it work? Well, it will return a true value or 1 every time a 1 appears in the input. And it will return a false or 0 value when there is no 1 in the input binaries. If we now take these values, x1 and x2, and place them on a graph, we get an image like this one. We can see that the point at 0, 1, 1, 0 and 1, 1 belongs to class 1, and that the point at 0, 0 belongs to class 0. This simply means that we took the output from the logical OR and we made classes from it. We made two classes, class 0 and class 1. And we want our logistic regression model to classify these points like this. When the points are above this line, they belong to class 1, and when they are below this line, they belong to class 0. The next operator is the AND operator. We can say that it is the opposite from the OR operator because it returns a value of 1 or a true value when both of the values or all the values are equal to 1. It will return a false value when a 0 appears in the input values. If we now take a look at this graph, the AND graph, we can see that this point here now belongs to class 1 at the coordinates 1, 1, and the rest of them belong to class 0. And we want our logistic model to classify these points so that the points above this line should belong to class 1 and below it should belong to class 0. And the last operator that we are going to talk about is the NOT AND operator. So we can see that it is the negated version of the AND operator. When we have two values of 1 or two true values, then the output is 0, and for the rest of the combinations it's 1. If we now take a look at the graph for this operator, we can see that the goal of the logistic regression would be to classify the points so that the points that are below this line should belong to class 1 and above this line to class 0. So, for example, this point at 1, 1 should belong to class 0, and these points below here belong to class 1. Now, let me explain why we reminded ourselves of how the logical operators work. If we take a look at the Xor table, we can see that we get a false value or a 0 value when both of the inputs are equal. So we have two zeros and we have an output 0. But we have a true value or 1 when they are different. For example, 0 and 1. By taking these points and placing them on a graph, we get something like this. We can see that we have two classes. Class 1 are the green dots and class 0 are the red dots. And also we can see that we cannot draw any line here that would separate these two classes like we did earlier, using the logistic regression model. So that is the Xor problem. How can we solve the Xor problem? We will take the following approach. We will first create a OR logical operator and we will classify all of the points with it, and then we will create a NOT AND operator which we will use again on the dataset, and then we will use a AND operator on the results from the OR operator and the results from the NOT AND operator. Let's now see how we can do this in Python using PyTorch. Let's start by importing the following libraries. We will import NumPy, Matplotlib and PyTorch. First we will create the data for the logical AND operator. So we will create X to be a NumPy array of 4 numbers. So as we did in the table, 0, 0, 1, 1, and we'll set the data type to be np.float32. And I will just copy this for the second feature. This will be x1, this will be x2, and for the second feature we will just change this up, so 0, 1, 0, 1, and we also need a y, which is the label or the output. So here the output will be 0, 0, 0, and just for the values that are equal, or just for the ones, it will be 1. And we'll set the data type to be also np.float32. And now if we take the data and we do a plt.scatter, we will scatter, for example, x1, x2, and the color will be depending on the y. So here we can see that we get a similar graph as we showed in the beginning of this video. So just this value here is a true value, or it has a value of 1. The next step would be creating a data set, because we cannot just train our data on these 4 points. So I'll create a function, create dataset, that will accept x1, x2, and y as input parameters. And then the first thing in here would be calling the function np.repeat on x1, and we will repeat these numbers 50 times. And then I will do this for x2 and y also. So I'll copy and paste it here, and I will paste y here. After this, we need to add some noise to our x1 and x2. So we will call this x1 plus np.random.rand. We want x1.shape 0, so this will probably return 200 numbers. And then we will multiply it with 0.05. I will copy this and just change it so it's x2 instead of x1. Now the next step would be shuffling the data. So I'll name it shuffle. And inside here I will create a index shuffle variable, and I will call the np.arrange function on x1.shape of 0. So this will return 200 numbers that are from 0 to 200. And then I will use the function np.random.shuffle on that index shuffle. And now we need to convert our data to be x1.sType to be float32s. Paste it here and just change to be x2 and y. And now we can apply this index shuffle. So I will do x1 is equal to x1, and for the index I will pass in index shuffle. And then I will just copy this 2 more times, x2, and we need to do the same for the y. And remember, because we are using PyTorch, we need to convert our data to be tensors. So we will create x1 torch, which will be a torch.tensor, or even better, from NumPy, and we'll just pass in that x1. We also need to clone it, so .clone, this is the same as .copy, and then we will just use the function view to reshape our data. This is the same as .reshape, just for tensors. And then I will do the same for x2 here. Also do it for the y variable, so y torch, y. And now that we have converted our data or transformed it into tensors, we can now combine x1 and x2. So I'll create a variable x that will be torch.hStack, so we'll stack horizontally x1 torch and x2 torch. And now the next step would be creating a training and testing dataset, because we mentioned earlier that we need a train and test set instead of just one training set. So xtrain, xtest, ytrain, and ytest. For the xtrain, I will call x and I will take the first 150 numbers. And then for xtest, I will just place it so it's the last numbers. Ytrain will be calling ytorch and taking the first 150 numbers, and then for the ytest, the same, just the last numbers. And at the end we will return xtrain, y train, x test, and y test. And now that we created our function, we can call it. So I will copy these variables from here and use them here, and call the function create dataset on x1, x2, and the y variable. And then for better visualization, I will just do plt.scatter xtrain 0th index, xtrain 1st index, and the color will be y train. And here we can see our data points now. Now that we have created the class for the logistic regression, we will call it here. So first we will need to create the model for the Endological operator. So model end will be equal to logistic regression, and in here we'll pass in 2 and 1 because our x now has 2 features and we want 1 output for the y. And then we will create a criterion. So criterion will be torch.nn, and we will use the binary cross entropy for the loss. So like this. And also we need to define a optimizer. For the optimizer we will be using the stochastic gradient descent. And in here we will pass in model end.parameters. We want to optimize the parameters, and we will set the learning rate to be 0.01. Now that we have defined everything we need, we will create a function for the training. So def train, we will pass in the model as input, also the criterion, so this, and the optimizer. We will pass in x, y, and also the number of iterations. I will name it iter. And then we will create a list, for example all loss, in which we will store the loss for each epoch. Then for epoch in range of the iteration, we will do the forward propagation. So y hat will be model on the x, and after the forward propagation we need to calculate the loss. So loss will be equal to criterion of the y hat and the original y, and then we will do the backward pass. But before the backward we will store the loss inside this all loss list that we created. So append with the loss item. After the backward pass we need to optimize the weight and the bias, so we'll do optimizer.step, and then we need to zero the gradient, so optimizer.zeroGrad. And at the end we will just return the all loss. Create a variable all loss, and we will call the function train, pass in the model end, criterion, also pass in the optimizer, x train, y train, and for the number of iterations we will set 50,000, for example. Now after it's trained we can check the results. So we will create y prediction, and we will use the model end dot forward on x test that we created. And then we will just do plt.scatter y prediction. We need to detach the gradient, so .detach, and change it to numpy. And for the second point we will be using the y test. And we can see how the classifier classified these points over here to be 0, 0, to belong to the class 0, and these points belong to class 1. We can also plot the loss that we saved, so plt.plot all loss, and we can see how the loss dropped here until it reached somewhere near 0. And now that we have trained our model end, we can now go and train our model OR. So first we need to create the dataset, so x1, x2, and y. x1 will be equal to np.array. It will be the same as before, so 0, 0, 1, 1. x2 will be np.array of 0, 1, 0, 1, and the y is the only difference, so y will be equal to 0 for the two 0 values, 1 here, also 1 here, and 1 here. I missed a here. And then we can scatter it, so plt.scatter x1, x2, the color will be depending on the y. And this is how the graph looks like for the model OR. We can see that this point over here has a y value of 1, this also, and this one, and only this value of at 0, 0 has a value of 0. So now we'll create X train, Y train, X test, Y test, and it will be equal to create data set on X1, X2 and the Y variable. And now I will just copy this from here, change it, so I will plot X1 for X2 and just place it. So this is the 0th index and this is the first index, and the color will be Y train. And now we have created our data set. After this we create our model or logistic regression and pass in 2 and 1. We also create criterion to be the same, torch.nn.bce loss, and for the optimizer we will use the same, torch.optim.stochastic gradient descent. We will optimize the model or parameters, and the learning rate will be the same of 0.01. I have an error here, so it's torch. Again, I will save all loss and I will call train using the model or, pass in the criterion optimizer, also pass in X train and Y train, and for the number of iterations 50,000. After the training we can just simply examine the loss, so plt.plot all loss, and by looking at this graph we can see that the loss was dropping, and it dropped below 0.1 and somewhere close to 0. And lastly, after training the OR model, we can now go and train the not AND model. So we'll create the data again, x1, x2 and the y. x1 will be a NumPy array. I will just copy it from here because it's the same, just the y is different, the output. So x1 and x2, and y will be also a NumPy array, and the numbers are just 1, 1, 1 and 0 here. So it's the negative version from the AND operator. And we will simply just scatter them, so x1, x2, the color will be y. And this is the graph. And after this we can just simply go and create the data set, so x train, y train, x test, y test will be equal to create data set, pass in x1 and x2, and also pass in the y variable. And also I just simply copy this, paste it here. We will scatter x train, oops, mistake, x train here, and we'll paste it so it's the 0th index and the first index, and the color will be Y train. And this is how our data set looks like. As we now have the data, we can create the model. So model not AND will be equal to logistic regression, and it will accept 2 and 1. Then we'll create the criterion, which will be the same, so torch.nn.bce loss. And for the optimizer we will use the same one, so torch.optim.stochastic gradient descent. We will optimize the model not AND parameters, and the learning rate will be equal to 0.01. I forgot the brackets here, and run this. Again, torch. And now we can go and train our data. So all loss will be equal to train, pass in the model not AND, criterion, optimizer, x train, y train, and 50,000 for the number of iterations. Now that our model is trained, we can plot the loss again. So all loss, and we can see that it dropped here again close to 0. And now we can finally create a Xor data set. We will be using the previously developed AND, OR and not AND logistic regression models to solve the Xor problem. Initially we will apply to OR and not AND, and those two outputs are used as inputs to the third one, that is the AND operator. And everything is the same as before. I defined here x1 and x2, the same values as before, just changing the y variable to be 0, 1, 1 and 0. And then if we scatter these points, so plt.scatter x1, x2 and the color will be y, we get this graph. So now we can create the data set. So xtrain, ytrain, xtest and ytest will be equal to create data set and pass in x1, x2 and the y variable. And then simply plt.scatter, we will scatter xtrain, 0th index, xtrain first index, and the color will be equal to ytrain. And here we can see our data set. Now to test this, we will test it on one number. So for example, we'll take the 5th number in the data set, and we will call this variable h1, and we will call the model or.forward on xtest of the 5th number, or are you just passing test. And then h2 will be model not end dot forward also on xtest of the test, and then h3 will be the model end dot forward, and we will call it on the output of these two. So we will create a torch.tensor, and in here we'll pass in h1 and h2. Then simply print out h3 and print out ytest of test. And we can see that we get a value that is close to 0, and the original value is also 0, so this is correct. And by just changing here, for example, the 3rd value, we'll print it out again, we get a value that is closer to 1, and the actual value is 1. After these two tests, we can now test this on the whole testing set. So I will just copy and paste this here and remove this index, and just change from .tensor to hstack to horizontally stack our data. The best way to visualize this now is by calling plt.scatter, pass in h3.detach to remove the gradients, and then just change it to be a numpy array and pass in ytest. By looking at this graph, we can say that the data was almost perfectly classified, meaning that it was classified as 1 or 0 correctly. By looking at this image, we can see that it is a computational graph for solving the Xor problem. So we can see here that we have h1 and h2, which are the values obtained after applying the model OR and the model not end on the x points. So this is this part in the code. We apply the model OR and we apply the model not end, and we obtain h1 and h2. And then we obtain h3 by applying the model end on the h1 and h2. So this is this part here, where we get y hat. If we look at the middle here, we can see that this part represents a layer of the neural network. So we can say that this example was a 2-layer neural network. And this approach revolutionized the application of neural networks. Another very useful approach would be engineering a 3rd dimension. So the first feature and the second one remain the same. We just engineer a 3rd feature here, the 3rd dimension. And the Xor output will be the same. So by looking at this image, we can see that we have created a 3rd dimension. And now, instead of a line that will separate these points, we can imagine that this is a plane that is separating these points. So now let's see how we can do this in Python. To create the dataset, I have taken apart the function from before, create dataset, because we have to make some modifications to it. So everything is the same here. The only difference is here, when we transform our data from NumPy to torch tensors, we here engineer the 3rd feature, so x3 torch, and we get it by doing some element-wise multiplications of x1 torch and x2 torch. And then everything is the same, we just add it to the original x, or the big X, and here we just split it into training and testing. Now comes the part where we create our model for the Xor. So I will name it model Xor, and it will be the same logistic regression as before, but now instead of a 2 feature, we will place 3 features here and 1 output. And now we will create the optimizer, which will be torch.optim.sgd, or stochastic gradient descent, we will optimize the model Xor parameters, and the learning rate will be the same of learning rate 0.01. And then the criterion will be torch.nn.bce loss, and just run this cell. To train the model, we will just do all loss will be equal to train, pass in the model Xor, pass in the criterion, the optimizer, x train, y train, and the number of iterations, which will be 50,000, and just train it. Now that our model finished training, we can now make some predictions. So y prediction will be equal to model Xor dot forward, and we will simply pass in x test. After the prediction has finished, then we can just scatter this. So plt.scatter, pass in y prediction dot detach to remove the gradients and to transform it into a NumPy array, and pass y test as a second argument. By looking at this scatter plot, we can see that our model made good predictions. And that would be it for this video. If you like this video, drop a like and subscribe to our channel. If you want to learn more details about solving the Xor problem, I will leave a link for the blog post in the description. If you have any questions, leave them in the comments below. Thank you for watching, and as always, be safe.